Hi, I'm Brian from Simply Brian Enterprises, and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico class, lesson number 2. In this lesson, we were instructed to wire up an LED to our Pi Pico and then send letters in Morse code SOS. So let's take a look at the hardware and get going on the homework assignment. So the first thing I want to point out is I've made some changes to my hardware layout. I've decided to reorient the board in light of my breadboard video so that the ground rail is on top. When I did that, because I had to rotate the board 180 degrees, I ended up moving my wiring. My wiring was over here. I had to move it over here. And I also had to move my Picos because my Picos would have been over here and I wanted them over here. So one of the conversations that came up in the chat last week in class was, wouldn't it be nice if we had a little device that could, slide under the Pico and kind of lift it up, maybe like a little beveled piece of plastic? And I realized I have such a thing in the form of a Lego brick separator. This has a nice little beveled front edge, and the width is just right to slide underneath and gently lift out the Pico. So I start on this side, and I can just kind of work my way, kind of work it out without bending the pins. Then when it comes to inserting it, it has a nice solid flat edge that I can use to kind of line up on the row of pins in both sides and just kind of work it back in. So that's kind of neat that this just happened to work that way. If you're going to 3D print something like this, design your own, I would make a couple of recommendations. First of all, I would shallow out this angle so that the device can slide under the Pico a little further on each lift. I would also make it just a little bit narrower. It does fit between the pins, but it's very snug. So if I were to design something like this, I'd probably take a few millimeters off here so that it slides under a little more easily. But in case you're looking for something to easily remove and reinsert your Picos, this is a great little tool for doing that. So just wanted to share that little tip with you. I've talked about my cardboard platform boards here, and I will continue to do so as I keep working on them. I've actually cut this a little bit shorter. What I found is that the camera couldn't quite reach to the back side of the board. And if you look at my lesson 1 video, you'll see that I had to basically pick this up and turn it because I had the breadboard back here and the camera couldn't really see it. So I've moved, thanks because it's all Velcro, I moved the breadboard assembly to the front uh, part of the board instead of the back so the camera can see it a lot easier. I think in future videos you're going to see this kind of slowly moving back because I want to have room down here to build things and add on. But that's one of the benefits of using cardboard and not having cut the actual plywood pieces yet. I can really work with this and get comfortable with it. That way, when I make the plywood piece, I'll know the correct dimensions by the time I've done with it. All right, enough about that. Let's get to our lesson. So first and foremost, it is a violation of FCC rules to send an SOS signal when you're not actually in trouble. So we're going to comply with FCC rules today. I'm not going to send a false or deceptive SOS. I'm going to send the phrase Morse code. And I want to talk a little bit about Morse code before we get into the program. So Morse code is comprised of dots and dashes, otherwise known as DIT and DA to more experienced Morse code operators or ham radio operators. And we have to consider the length of each segment. So I was trying to find out, is there actually a definition of a single DA or a single DIT? Is there a universal term for this? And there's really not. But I did find a document that referred to these as a signal burst. So a DA is a single signal burst. A DIT is a single signal burst. Had to be careful how I said that. So I like the idea of just calling them bursts. I think that's perfectly acceptable and it gets the point across. So what is the length of a DIT burst? What is the length of a DA burst? Is there a defined length between bursts, between this DIT and DA? Is there a defined space between letters? So here I'm going from the letter C to the letter O. Is there a defined space here? And is there a defined space between words? And as it turns out, there are internationally accepted uh, measurements for these. So there's a little bit of math involved in figuring out the length of a dit. So I'm just going to start off here. You may or may not be able to see this. I'll show you when I'm done writing here. We're just going to call a dit x milliseconds. And then the length of a DA is internationally known as 3 dits. So we can say a DA is 3 dits. The space between bursts, so here we have a DA and a DA, the space between this is commonly referred to as the relax. And if you think about a person who's sending Morse code using a Morse code keyer, if I send a DA and then I lift my finger, I'm relaxing my finger between that DA and the next DA. So this is called the relax time, and the relax time is universally understood as, oh, I'm sorry about that. The relax time is universally known as 1 single dit. The word space, the letter space, here we have a space between the M and the O. This is 3 dits. And then the word space is 7 dits. So we have this nice universal nomenclature, but the thing we don't know yet is what is the length of a dit? We define that as x milliseconds. How do we refine that a bit? Well, in Morse code, we determine the speed of a Morse code transmission in words per minute. Beginner Morse code is 5 words a minute. More intermediate Morse code is around 13 minutes. 13 words per minute. That's where the more proficient operators run at. And then the more advanced level, you get up to 20, 30, even 40 words a minute for those who are really experienced. That's not me. So we'll stay with 5 and 13 for this lesson. So how do we determine the length of a 5-word transmission? If I have 60 seconds to send 5 words, what is 5 words actually equate to? Well, the universally accepted word is Paris. And what we find out, if we translate the DAs to dits, so 3 dits per DA, we do a dit for the words, a dit for the relax, 3 dits for the letter space, and then we tack on a 7-dit word space, we find out that the word Paris is exactly 50 dits long. So in a 5-word per minute transmission, I'm going to send 250 dits in 5 minutes. In 1 minute, because it's 5 words, 1 minute, 250 dits per minute. So if I divide that by 60, I get roughly 4.16 dits per second. And then if I want to convert that to milliseconds, I'm going to take 1,000, divide by 4.16, and I get right around 240 milliseconds. 240 milliseconds is close enough. But I don't want to do all that math every time. So is there maybe a shortcut? As it turns out, there is. If I take 240 milliseconds times 5, my speed in words per minute, I get 1,200. So I can actually shortcut the process by saying 1,200 divided by words per minute equals my dit length in milliseconds. So if I have a 5 words per minute transmission, I'm going to get a 240 millisecond. If I'm going to do a 10 words per minute transmission, I'm going to get about 120 milliseconds. Stands to reason, right? Your dit length is going to be half if your code transmission speed is twice the speed. So it seems to work out pretty well. And then if we go to that 13 proficiency words per minute, we get about 92 milliseconds per dit, which seems pretty reasonable. Now, normally I would run the program and then we'd look at the code, but today we're going to do a little different. We're actually going to look at the code first because I want to point out a couple of things in the code before we run it. So sorry about that, move my mouse pointer. So from machine, I'm importing pin, and I'm doing a little throwback to an earlier Raspberry Pi class. I'm going to import that as kitty litter box, just to show you that we can import pin as anything we want to. And from time, I'm going to import sleep, and I'm going to call it a CW pause. CW is short for continuous wave, and in the radio service, Morse code transmissions are often referred to as continuous wave or CW. What that means is that when the Morse code is sent, it sends a sine wave that is a fixed amplitude and a fixed frequency. And it's over and over and over and over and over. So if you were to look at it on an oscilloscope as somebody's transmitting, you would see this perfect waveform that is the same amplitude and same frequency regardless of what's being sent. So that's referred to as continuous wave or CW. So I've chosen to use the term CW for my program. So here I'm wiring up the LED to GPIO pin 11, and I'm going to set my words per minute to 5. That's beginner speed. And now that I've done that, I can do the rest as just math equations. I don't have to make any changes to my other speeds. So DIT speed, I'm taking 1200 divided by my words per minute, and then I want to convert it from seconds to milliseconds because I'm sorry, from milliseconds to second, because the Python sleep command takes full seconds. So I need to take my speed in milliseconds, convert it to seconds by dividing by 1,000, and then I'm going to force the float data type. Now, Python should figure that out automatically, but I've run into cases where Python doesn't always guess the type correctly, and I don't want it to truncate any of these equations. So I'm going to force it to go to float, even though I probably don't have to. And then we get to our DAW speed, which is 3 dits, our relax, which is a single dit, our letter space, which is 3 dits, and our word space, which is 7 dits. And here I'm setting up my LED as an output pin using Kitty litter box instead of the pin nomenclature. And we're going to turn the LED off before we do anything. Now, this is why I wanted to show you the code before I run the program. We're actually going to run a couple of characters, or I'm sorry, we're going to send a couple of characters before we get to the phrase Morse code. And the reason why is because in a radio transmission, we want to prepare the sender, or I'm sorry, we want to prepare the receiver for what we're about to send. And so we send this abbreviation of AA, or all after, which means what I send on hereafter, you want to write that down. That is my message to you. So I'm preparing you, I'm going to send a message. And so we're going to send an AA signal, and we're going to send it twice. So in order to do this, I had to really think about how advanced do I want to get with the code. I decided since this is a beginner course in Pi Pico, I was going to take the long and efficient way around to write the code. There's certainly better ways to do this using for loops, functions, or lists. Do want to do a quick shout out here to Lori and Charlotte for using dictionaries. I think that's a great way to do it because then I can just call up the letter value instead of actually having to think through dits and das and relaxes and spaces. But because this is a beginner class, I decided I'm just going to walk through this very manually for each letter. So here I'm turning the LED on, pausing for a full dit, turning the LED off, pausing for a relax, turn the LED on, pause for a DA, turn the LED off, and then I'm going to do a letter space. Then I'm going to send another A. LED on, dit, off, relax, on, DA, off, relax. Where am I at here? There we go. And then I'm going to send a word space. I'm sorry, there's no second relax. That's why I was kind of messed up in the head there. We're going to do a word space between the AAs, and then we're going to send it again. We're going to do 2 sets of AA to prepare our receiver for the message we're about to send. And then when we get past that, I'm just going to do a while loop to send the actual Morse code message. And here you see I'm just turning it on, pausing for a DA, turning it off, relax, on, DA, off, letter space. Then we go to O, R, S, E, and so on and so on. So I'm going to go ahead and I'm going to run this program, but first I'm going to flip over to this view so we can see it a little better. I want to turn on this little lamp because what that's going to do is it's going to help the camera see the LED better. And so let's start the program here. We're going to do, first we're going to do a dit da, dit da, dit da, dit da. So there's our AAAA. Now we're going to send our da da, da da da, dit da dit, dit 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 dit, word space, da, dit, da, dit, dit, and so da, 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 dit, dit, dit. And then it's going to loop around and it's going to keep doing that over and over and over. Now, if we want to change the speed, come in here, I'll flip back to my code view here. All I need to do is come over here and set my words per minute to 13. Oops, this keyboard is it's kind of a tricky thing. The Raspberry Pi 400 keyboard is a little tricky, but here we go. We're going to speed it up a little bit. So now you can see we're sending a lot faster. We're now sending 13 words a minute as opposed to 5. And you can see it's got a lot more steady blink to it. So that was a bit of a long explanation for something that could have been simple, but I thought that between the hardware changes I made and the opportunity to really dig into Morse code, I thought it was worth the little bunny trails we went down. If you like this video, please hit like and subscribe below. Hey, I'm excited. My subscribers have doubled in a week. I'm now up to 25 subscribers, so thank you. If you're a new subscriber, I really appreciate that. For Simply Brian Enterprises, this is Brian, and I will see you next time.